Good day, everyone. My topic for today is all about NanoWorld. NanoWorld, also known as the world at a microscopic level. What is nano? The word nano is from the Greek word nanos, meaning dwarf. Nano is a prefix used to describe 1 billionth of something. What is nanometer? Nanometer is a unit of measurement that is equivalent to 1 billionth of a meter. It is widely used as a scale of building tiny complex and atomic scale computing and electronic components, specifically in nanotechnology. How to view nanomaterials? Scientists use special types of microscopes to view minute nanomaterial. During the early 1930s, scientists used electron microscope and field microscopes to look at the nanoscale. The scanning tunneling microscope and atomic force microscope are just among the modern and remarkable advancements in microscopy. Electron microscope. German engineer Ernest Ruska and Max Knoll built the first electron microscope during the 1930s. This microscope utilized a particular beam of electrons to light up a specimen and develops a well-magnified image. Electron microscope produce higher and better resolution than older light microscopes because they can magnify objects up to 1 million times. In comparison, conventional light microscopes can only magnify objects up to 1,500 times. Scanning electron microscope and transmission electron microscope are the two available electron microscopes. Atomic force microscope. It was first developed by Gerd Bing, Calvin Quate, and Christoph Gerber in 1986. It makes use of mechanical probing that gathers information from surface of a material. Scanning tunneling microscope. This special microscope enables scientists to view and manipulate nanoscale particles, atoms, and small molecules. In 1986, Gerd Bennig and Heinrich Rohrer won the Nobel Prize in Physics because of this invention. What is nanoscience? Nanoscience is the study of structures and materials on an ultra-small scale. Nanoscience is cross-disciplinary, meaning scientists from a range of fields including chemistry, physics, biology, medicines, computing, material science, and engineering are studying it and using it to better understand our world. Nanoscience is a knowledge of a small scale. Nanoscience is also known as a knowledge of a small scale. What is nanotechnology? Nanotechnology, also shortened to nanotech. It is the use of matters on an atomic, molecular, supramolecular scale for industrial purposes. Nanotechnology in science, engineering, and technology conducted at the nanoscale, which is about 1 to 100 nanometers. Nanotechnology is about looking at the world on such a tiny scale that we can not only see the atoms that make up everything around us, including ourselves, but we can manipulate and move those atoms around to create new things. Think of nanotechnology then as being a bit like construction, only a tiny scale, and I do mean tiny. The nanoscale is 1,000 times smaller than the microscopic level, and a billion times smaller than the typical world of meters that were used to measuring things in it. Nano literally means 1 billionth. If you took a human hair, for instance, it would measure approximately 100,000 nanometers wide. That's the sort of scale we're dealing with at a nano level. The concept of nanotechnology and nanoscience started on December 29, 1959, when physicist Richard Feynman discussed a method in which scientists can direct and control individual atoms and molecules in his talk, "There is Plenty of Rooms at the Bottom," during the American Physical Society meeting at the California Institute of Technology. Professor Norio Taniguchi coined the term nanotechnology a decade after the dawn of ultra-precision machining. Here are some examples and application of nanotechnology. Number one is this electronic. Carbon nanotubes are close to replacing silicons as a material for making smaller, faster, and more efficient microchips and devices, as well as lighter, more conducive, and stronger quantum nanowires. So, example of the electronics that we are used nowadays are the computers, televisions, printers, and others. Next is the energy. A new semiconductor developed by Kyoto University makes it possible to manufacture solar panels that double the amount of sunlight converted into electricity. If you can see the pictures, it shows a solar panel, a electricity tower, and then a windmill that produces electricity or energy. Next is the biomedicine. The properties of some nanomaterials makes them ideal for improving early diagnosis and treatment of neurodegenerative diseases or cancer. So, they discovered the medicines that will cure the different diseases or illnesses like cancer. Number 4 is the environment. Air purification with ions, wastewater purifications with nanobubbles or nanofiltration systems for heavy metals are some of the environmentally friendly applications. So, as you can see the picture, our surroundings. So, our surroundings is an example and application of nanotechnology. The fifth one is the food. In this field, nanobiosensors could be used to detect the presence of pathogens in food, or nanocomposites to improve food production by increasing mechanical and thermal resistance and decreasing oxygen transfers in packaged product. Okay, so as you can see in the picture, fruits, vegetables, so are example of nanotechnology. And then the last one is the textile. Nanotechnology makes it possible to develop smart fabrics that don't stain nor wrinkles, as well as stronger, lighter, and more durable materials to make motorcycle helmets or sports equipment and others. As a conclusion, nanotechnology in the future, there are bright and dark spots in the future of nanotechnology. On the other hand, the sector is expected to grow globally, driven by technological advances, increased government support, increased private investment, and growing demand for smaller devices, to name a few. However, the environmental, health, and safety risk of nanotechnology and concerns related to its commercialization could hamper market expansion. Thank you for listening, everyone, and may God bless us all. Bye-bye!